video of section 1.8 of the Green Book, Symbols into Words. So in the first few questions, we're simply going to translate, and I'm going to use X for the number. And we have something new here. We're going to be talking about its square. So we want to know that that's X to the second power when we have the numbers square. And because we're talking about the difference, we know order matters. So the difference between a number X and its square is X minus X squared. In a similar way, we're going to use X for the number in number 2. We know that 7 subtracted from a number is 9 means that we're going to have an equation. And order matters, so X minus 7, 7 subtracted from a number, the number comes first, and then subtract the 7, is 9. We're going to skip number 3 because there's a typo in there. And then for number 4, we have twice a number decreased by 7 is 35. So again, that's going to be our equal. So 7 decreased, twice a number decreased by 7 means 2x minus 7 is 35. All right, so let's take a look at our first word problem in number 5. We have the base of an isosceles triangle has a length b centimeters. If the perimeter is 120 centimeters, find the length of one of the legs in terms of b. That means that we're going to find what the side is, but the answer is going to have, we're going to find what the base is, but have b in our answer. So let's go ahead and draw a triangle here, and I'm going to try to make sure we know what an isosceles triangle is. So an isosceles triangle has at least 2 of the sides equal, and in this case the b is the base. So again, we could label that here, and then because at least 2 of the sides are equal, I'm just going to come up with a variable, and I'm going to say that x is equal to the legs of the triangle. Okay, so we know that the perimeter is adding up all of the sides. So we know that the perimeter here is going to be x plus the base. And if we simplify that and plug in what we do know, which is that the perimeter is 120, we would get 120, which is the perimeter, is equal to 2x plus b. Well, what did they ask us to do? They asked us to find the length of one of the legs, which is x, in terms of b. That means that we're solving for x, and b will be in our answer. So what I'm going to do is subtract b from both sides. This is just like our literal equations work that we did, and get 120 minus b is equal to 2x. And then to further isolate or get the x by itself, I'm going to divide both sides by 2. So we would end up with x, one of the legs, is equal to 120 minus b over 2. We could certainly accept that as an answer, or we could write that as 60 minus b over 2. Either one would be okay. All right, so again, terminology is important, and we need to know an isosceles triangle has at least 2 legs that are the same. All right, so some formulas. We're going to be working with our distance formula. This stands for rate times time equals distance, and so we'll see that used in our chart format that we've done before. We want to know some things about angles, and if we have x as an angle, then if we want its complement, the complement and its angle always add up to 90 degrees. So the complement to an angle, we would start with 90, subtract out one of the known angles, and then we would get its complement. In a similar way, the supplement adds up to 180. So 180 minus x would be the supplement. So I always think of a complement as a 90 degree angle, and we have, because there's a corner, I think of complement. They both start with a C. And then if we think about a straight line, we know that a straight line is 180 degrees. So again, I think of the word straight, and that goes with supplement. So that's only if you get those two confused. That's one little way that you can try to keep them apart. All right, so we have now just a quick translation using our distance, or rate times time equals distance. If Anne is biking at r miles per hour, use the variable r to represent each word phrase by an algebraic expression. So Anne's speed, if she drives 5 miles per hour slower, would be r minus 5. If she drives 5 miles per hour faster, would be r plus 3. And the one that might be new is that the average speed of Anne and Juan's speed, if Juan's speed is 10 miles per hour. So recall that an average is adding up all of the terms and dividing by the number of terms. So here we just have two terms. We have Anne and Juan and their speeds. So again, we're using r for Anne's speed plus 10, which is Juan. And because there are two speeds, we're going to divide by 2. That would be one way to express it. Or, because we know that that denominator applies to both terms, we could write it as r over 2 plus 5. Either one would be okay. All right, so let's go ahead and look at a motion problem with rate times time equals distance. So recall that if you think about direction symbols, we think of north as going up, south as down, east is going to the right, and west is going to the left. So here we have a helicopter left at noon and traveled east at 110 kilometers per hour. 1 hour later, a light plane left the same airport and traveled west at 300 kilometers per hour. We want to know how far apart were they x hours after noon. And we're going to express our answers in terms of x. So we're not actually solving anything, but what I'm going to do here is just kind of draw some segments, and I want you to think in terms of the two pieces that we have. And for this one, I'm going to try to connect that to the blue a little better here. Actually, I'll just connect. There we go. All right, so if I add that one, let's go ahead and think about the two pieces that we have. So going east at 110 kilometers per hour, if in this case, we would say, because they've already defined it for us, that the x is the number of hours. So x equals number of hours. So going east at 110 kilometers per hour, we could express the green portion as 110 times the x. So the rate times the time. And then going west, they left 1 hour later. So the question is, how do we express that? Well, if the number of hours is x, 1 hour later means they're traveling 1 less hour than the eastbound. So we could express that as the rate, 320, times the quantity of x minus 1. And we want to know, again, how far apart were they? Where their total distance is just going to be adding up the two segments. Remember, what I drew in blue is representing the distance westbound, and what I wrote in green is representing the distance eastbound. So the total distance is 320 times the quantity of x minus 1 plus the 110x. So if we distribute and simplify, let me just clean that up a little bit. If we distribute and simplify, then we can give our total distance in terms of x. So 320x minus 320 plus 110x. If we had 110 and 320 for our like terms, we get 430x minus 320, and that's going to be our total distance. I'm going to write TD for short. All right, the next concept in 1.8 we have covered thoroughly. That is on consecutive integers. So I'm going to skip the review for that and get right to an example problem, just to show what we can, or how it's affected if we label our unknowns differently. So this says, what is the sum of 5 consecutive odd integers if the first one is x? In other words, they're telling us that x is the first one. And then let me just actually go up here and do first, second, third, fourth, and fifth. So then we can see that we would have x, because they've defined it that way. X plus 2 would be our second. X plus 4 is our third. Just as a reminder, these are odd. That's why I'm adding by 2. And so if we wanted to then express the sum of those, all we would do is add the 5 pieces together. And when we simplify, we're going to get 5x plus 20. Well, what if they told us the middle one is m? Again, I'm going to keep that column, but now I'm going to write m in the middle for our third or middle unknown. And then thinking, well, instead of adding 2 to get smaller, I would subtract 2. And to get to the smallest one, I would subtract 4. And then going the other way, as I get bigger, I'm going to add 2 and add 4. So if I were to express the middle one and the sum of those, then when I add my like terms, I get 5m, but my constants cancel. And so I'm just left with 5m for the sum. What if I say the next to the largest is n? So here, the next to the largest would be the fourth one. Going up, I would get n plus 2. Going down, I would get n minus 2, n minus 4, and n minus 6. So if I added my like terms here, I would get 5n minus 10. So we can express it differently depending on how we define our x. All right, so here we have the length and width of a rectangle are consecutive even integers, and the length is L centimeters. So consecutive even integers, the length is L, so they've told us that we don't have a choice. Remember, our width is our smaller of the two. Width is smaller than length. So if they're consecutive even integers and we know that the length is L, then the width would have to be 2 less. So I'm just going to, again, even though it was defined in the question, put our length here. So we know the two sides, and we just want to review some formulas. Area is length times width. Well, we now know that the area then in this question would be L times the quantity of L minus 2. If we simplify that, we're going to distribute the L to get L squared minus 2L. If we want the perimeter, we know that we're going to be adding up all of the sides. So 2 of the widths plus 2 of the lengths. And given what we know about width being L minus 2, it's going to be 2 times the quantity of L minus 2 plus 2L. When we simplify here by distributing and then collecting our like terms, we get 4L minus 4 for the perimeter. All right, so our last question here is just going to use the concept of complementary and supplementary. An angle measure has x degrees, so it's telling us that that's the variable that we're going to use. and we want to find the average of the measures of the complement and the supplement of the angle. So please recall from the notes that I did a little bit earlier that the complement, if x is our angle, is going to be 90 minus x. The supplement, remember supplement straight line, the supplement of our angle is going to be 180 minus x. If we take the average, we're adding the two together and dividing by 2. So our average of the complement and the supplement would be 90 minus x plus 180 minus x and divide by 2. So that's going to give us 270 minus 2x over 2. Here we would be required to simplify because I have a common factor of 2 in both terms of the numerator. 270 divided by 2 minus 2x over 2 gives us 135 minus x. We would have to take that final step in order to simplify. That concludes our video on section 1.8.